So, so the idea today is kind of share with you the problems we had when moving to like a more traditional architecture to a streaming asynchronous architecture. So I'm gonna go through the challenge. I want to just give you context why we're doing this, and then I'm gonna show you the first try we had at it, and then what we learned and where we are today. So the challenge we have is we are building a new subscription business. So if you know Doodle, you go to participate, you show in an ad, is that how you make money, but we believe in long term, our features is a subscription business. And we strongly believe that in 2 or 3 years, it's gonna be a much bigger business than it is today. So that's the first challenge we have. And now we're building a whole new scheduling toolbox for business professionals to be able to support this new business. And we have big ambitions, we really do. So if you think quite recently, we were launching partners with Google for AMP for email. So we went to Tokyo and present like what we've done. So one of the products out there, first product. We released a new chatbot with Slack, with the new SDK for Slack. We are launch partners as well. And recently we have a new product which is called Doodle 101, I think. And I'm sorry. And it's a whole new product we have out there now to support this new business. And we have 30 million monthly users to support still. So how do you do all this at the same time? It's quite challenging. So we have a monolith, right? And it's really static, because if you look at our code, there's static everywhere, and we can't change anything. So it's nothing new, Monolith 101, you all know it, legacy code, business logic that you don't know what is there for. It breaks for an operant reason. Actually, we have one class at Doodle which is in German, so there are some people that don't understand what the class does. And as the team grows, it becomes unsustainable to everyone change what's in there, right? Because how many hands you can have in a plate at the same time? And the list goes on. I don't need to tell you, know this. So at that point in time, we have a wish list, let's say. We want to move to a service-oriented architecture. I can tell you, I can use the name, microservices if you want, but no, whatever. Now you want to be decoupled from the monolith. It's quite important because it's static, something that doesn't grow as much as we want to. It's not sustainable. And you want to enable growth. We have ambitions. So we start toying with Kafka. So can we use Kafka to actually enable us to do what we need to do? So if you don't know Kafka, I'm going to try with 4 bullet points explain what it is, and I'm sorry for the oversimplifications. Basically, we have brokers, which are the servers you send a message to, and you have events that are stored in topics in these brokers, and topics are partitioned. So you can say my topic A has 16 partitions, and if you have 16 brokers, you divide each partition of that topic in each broker. It's a way to partition and to scale. So when was our first opportunity? So we had that in our mind, we had the challenge, we know something that could fit well. We had an opportunity to do that with Intercom. I don't know if you know Intercom. Is a product that when you go to a website, there's a pop-up on the bottom right that says, hey, can I help you? I am Laura from Doodle. And then you can interact with that, and then you can engage with the users. So the basic idea is just push things that happen at Doodle.com to Intercom, and then the product guys can go and build workflows based on this user behavior. And then we can increase user engagement by emailing them if this workflow, the rule for this workflow is true. So for example, email user X if after 7 days no one creates a poll, for example. That was the basic idea. So a Kafka-based solution made great, we have all these events, let's just push this to Intercom. It can be completely decoupled from the monolith. The monolith doesn't need to know anything about it. Perfect. So the first question we had to answer is, where do we push these messages? Which message to push? So we looked at while we did things before, and we had lots of log calls for events that happened at Doodle. For example, Doodle created, Doodle participated, let's say user sign up, user signing. And then this looks like what we want. So we identified where we call this in the log, where we write that, and we pushed in the same points. And then each event had its own topic. So the basic idea is that you have here a very basic, you have the topics here, you have a consumer that reads from the topics, you have a model mapper, we synchronize Intercom, and you hit it. Very simple. So we implement that the first version using a consumer and producer API. Spring Kafka, we are mainly a Java shop in the backend, And the first day we sent 20 million events to Intercom. We hit all the rates. The guys were calling us, stop please, and I had to go all the things. But most importantly is the first version was in production within 2 weeks. That's amazing, because if you look at the Monolith, legacy, can you change that, deploy, doesn't work. So no, as far as we're concerned, big win, success. So great, so we moved on. That's great, it worked, it's what we want to do, supports our vision. So a next step, right, what is the progression from that? Now is to use streams. So it's a natural progression from the API, the consumer and producer. It promotes team dependency through data independency. That's quite important, because as Doodle scales, it scales the team, the number of people working, and it's quite hard if they have lots of dependencies. So we thought that's a good way to do that as well. It's a good fit to increase velocity. And it can reduce operational overhead. What I mean by operational overhead is Kafka streams, if you don't know, there's things called state stores, right? Then you don't need a database. You can use local state to mimic a database. So what was the idea, okay? What was the premise? The premise is now we will use command query responsibility segregation. The basic idea is now going to separate the paths for writing and for reading. And we're going to have all this state in Kafka, and we could create these specialized views based on the needs of every product. Perfect, right? So service Z needs these 3 views, the 3 data from these three models to create a view. Just go from Kafka, pull them, and create your local state, and fine. Great. I don't know if you know this term, the inside-out database, or like making the database inside out. Something is a quite common term if you start looking at streams and asynchronous architecture. If you don't, please have a look at it, because it's quite important. That's the idea behind it. But most important to me was, I really wanted the team to start building service around data, not data around services. Because if you think the way we explore our data was very much what in the log? What does the application tell me? But it should be the other way around now. Our value is in the data. So we derive information from there and build things on top of that. It's a very important concept as well. So we moved on. No, we build the stuff, we create the streams, and we start deploying Kafka streams application. These were based on topics we had previously done from the logs, and it worked. Great. Until it didn't. It broke. So the experience we had, I was trying to find a way to show you the experience you had. And the best way I could find it was this GIF. So, in dev, it kind of does its job. It's there, it's not really great, but it's kind of working, and you feel comfortable. Well, maybe you can put that in production. Let's put in production. And then you are hit. And then everything breaks. And then you go home, look yourself in the mirror, and what I have done. So I want to show 2 cases, okay? I want to show 2 cases when that happened. The first one was we deployed a set of services, streams applications, and we started monitoring. We used Grafana and Prometheus to monitor that. And within 2 hours, we saw the total messages in Kafka from 100 million, 150 million at the time, to 300 million messages in 2 hours. And at this point, the ops teams were like, what's happening? And then we pulled all the business together, let's try to solve this. And no one works anything else, let's try to solve this. And then start find what happened, and we found this one topic that it had this spike of events being sent, and it just couldn't work out why. And then you come to me and say, look, at least these messages are being sent to Kafka in a sync way, you won't block anything, right? Right? Well, so when we firstly implement our Kafka integration in Monolith, we set the acknowledge mode to 3, which means you send a message to Kafka and we wait until every single message replicates across all the brokers. And the Monolith is like, I haven't got an acknowledgement, I will not reply to any requests. And then Doodle.com was like, response time. At this point, the whole Doodle was like, what's happening? Okay, case 2. We had all these topics. We were like, okay, great. So we want to build a new dashboard. If you go to Doodle.com, the dashboard was a bit old. So let's unify the user experience. Let's aggregate all the updates. Everything has all domains, put in one place. Streams. So I will try to explain the problem with Beam. So we had this state in the monolith, right? And you have our Kafka. And then we start streaming the events into Kafka. Great. And then we said, ooh, let's rebuild the state there. What really happened was, we got the head, we got the legs, and then had the torso, It just doesn't work the way we think. And the reason why we end up with these Frankenstein's entities and resources, what do we do with this? It doesn't work for us. So that's the main problem we had, and I want to share with you the lessons from this problem. The first one is really watch out for gaps and stand back a bit if you can. Sometimes you can't, but when you can, you do it, because we don't really have this, at least now, every single place I worked, we don't really have, I never had this culture of, let's scrutinize success case. We look something that worked, hey, that's great, it worked. Let's just continue. And was in this case, if we had a day that we could sit down and say, look, let's think about how we use things, we wouldn't continue with the same approach. The lesson number 2 is deriving state from events is hard, is really hard. There's no guarantee that how fast you're going to receive these events and in which order. There's no way what is going to be processed first. And sometimes, what is even worse, you need business logic. Your business logic requires historical context, which is lost. You don't have it anymore. So sometimes we need to build a new resource based in 5 events, but there's some interdependence between them, and you need to know something happened 2 years ago if this is valid. There's no way around it. So just to give an example of the problem we had, so we have these 2 topics. Imagine these 2 topics, and you have one is participation created on the left, another one is participation deleted on the right. So when you go to Google, you participate, I want to meet in this time, and after you want to change, it's participation deleted. And now, one we had like millions and millions of events a day, just popping up. And the second one we had just like thousands. So if you look at this, what is likely to happen? You can guarantee, but it's much likely that we'll get the message, the red message of deleted before created. And then I will ask this question to you. What do you do when a resource that doesn't exist yet is deleted? Back to the future, There's no one in your company will tell you, do this, because there's a case that doesn't exist. So lesson number 3, historical data shouldn't be an afterthought. So we learned that it's very easy to get started. We can build our streams very easily. We can build our apps and put up there and have the events flowing, then start merging things, great. But importing historical data, what about the last year, 2 years, 3 years, is really hard. It's not as simple just like emitting events to the topics that has everything, because you might have downstream jobs that will process these events. So you end up with a chain of reaction that you don't desire. And sometimes involve multiple domains at the same time. You need to combine information from multiple domains in one place. And like our experience is sometimes will take like multiple times the time to build a service, actually to import the data. So it will take much longer to import the data. So you'll do the service in days, it will take weeks to actually feed the data needed. So number 4, streams require a mindset shift, and this is hard, this is really hard. So they have a different mental model. Now we are used to code in a way, we used to code in a very, declarative way. We go and we tell what to do, we control the time. But the problem with stream is everything you do is dependent on the time, it's time bound. And this is really hard to replicate when you're developing, and it's really hard to think because we're not prepared for that. Just to give an example again, there's a practical thing. There's a Grafana chart from an import job that I created. And when I run it for the first time, I had 1 million messages. I run the same code with the same data for the second time. I had 6.5 million messages. The same code, the same date for the third time, 17 million messages. So some systems are more distributed than others. What I mean by that is, if you think about service-oriented architecture, some people would argue they are distributed systems. And I've been doing microservices for years, I know how to deal with them. And I'm here just to put this out there. Maybe if you do design-driven, REST-based architectures, they're not really distributed systems. They don't exhibit the main core functional properties of a distributed system. So a synchronous platform, a complete different beast, they are really distributed, and that's where you have problems. So okay, so that's what we learned. The problem we learned. So where do we go from here now? What do we do? So no, we asked ourselves this question, like, what do we do, what we learn? So we had some time to think, and we said, like, look, what is the fundamental question we're trying to address? We really want to enable Doodle to be faster, to deliver stuff fast. That's what we want to do. That's why we believe Kafka is the right approach. So we thought a bit like, how can we do that? And then the reality is like, we sunk us. So like, okay, now we had this eureka moment. The reality is, no, we were setting ourselves up to failure. And the reason for that is that the world is different than you think in your head. And there are two things that when you understand, it helps you to model distributed systems. The first one is the CAP theorem, which basically says the three main core properties of a distributed system, which is consistency, availability, and partition tolerance. And when you have Kafka, partition tolerance is a given. You need to have partition tolerance. You get that from using Kafka, right? So you have these other two left. And at some point, you need to make a choice. You need to compromise either inconsistency and availability. And we in this room, most of us at least, we're not programmed for that. We are programmed for 100% success. We need to guarantee state. We guarantee that the request will be fulfilled. But I'm telling you, that's not possible, so stop it. The second thing is, on top of CAP, you have base. So we are used to the ASCII properties of a database, right? But a base is like distributed system. They give us, or like they behave in a way that they show these base properties, which is basic availability, state, soft state, and consistency, event consistency. So basic availability say, look, doesn't matter what, if you request something, I will give you something back. But it might not be the right thing, but you get something back. The soft state is, look, even though you might not have any input in the system, there's nothing happening there, you might have a change of state. Because we're syncing up. Because things happen, so things are up and down. The third one is event consistency. So eventually, we'll sync up. Eventually, your state's going to be right. When? Don't know. So if you learn to live with these two things, if you go to bed and say, look, I have no choice, and I will need to design around this, that's one mistake we made. We didn't do that, and now we did. So we thought a bit more. So we know this thing now, we know what we're going to get, we know the problem, we know what caused the problem. So where we are today, so where we are going. So today, based on this learning, we are creating a data market at Doodle. So what is a data market? The idea is to use Kafka as our source of truth, and to make historical data available at will. So any new service or new product they want to experiment, they can go just open a consumer, open a stream, and just process data from historical times. And the very first step to get the monolith out of the way. I think we all have this idea that it's good to get rid of the monolith. But again, it's really hard to do it. If any one of you has been part of projects of trying to do it, you know the frustration. I've been, unfortunately, part of 2 projects I never finished. And half of the team quit before finishing it, or half finishing it. People are really frustrated. Look, again, let's make peace with it. We're going to have this for a while. How can we make this not as relevant as before? So get the data out of it, removing the silos, first step. So that's what we're doing. So we're doing this through what we call state and event topics. So a state topic has a long-term retention period and has a whole state of our entities, of our resource. And then events, in this case now, they become ephemeral. We don't care about events as much as before. So they're basically just to poke at you, something happened to this thing here, something happened to this thing here. You're not supposed to actually look at these things and try to rebuild state from it, because we have the state now. So the first step is get the monolith to start publishing all these domains they have into Kafka, and then we make this data market. This is a very oversimplistic solution, like overview what that is, because once you go into the details, we have lots of problems. So we have Martin here that he created the first, together with Nicholas, the first state domain topic in our infrastructure, and he started investigating monolith. So we start seeing things like we couldn't believe. So for example, every time you save, we have an update on a user in Doodle. Sometimes the same method is called 5 times. There are 5 database updates. They do different things. Sometimes you need one update before the other. And how do you manage all this? Now you can just put okay, when updates, send this to Kafka. There's a lot of work involved. It's quite hard. So don't make this step, don't oversimplify this step as well. Less less is more, like sort of. We want to avoid ground-up remodeling. I think we all have this tendency in engineering to stop, try to build something new, and you're like, oh, now I have this perfect thing, and then I want to actually start building on top of it, and then product comes to us and say, actually, we need to change this now, and the thing is like, ooh, it's too old now, we need to change again. So we don't want to do that. What we want to do is basically just see what we have now, look at the use cases, and say, look, is there any tweaks we can make? Like actually will save a lot of time. Do you know, like the 80-20 rule? Then 20% of work can do now that can help us 80% of the job. And then it's about asking the right questions. So for example, for the use state, we saw that like every time we need a use state somewhere, we kind of need the calendar state as well, because Doodle is all about calendars. So we thought, shouldn't we just merge both and like make this available everywhere, because it will save calls everywhere? Yeah, we should. So we did that, but we didn't remodel the whole user entity, because we knew there's something wrong there, but for now we can live with it. So the other thing that is quite important is this thing called single write principle, because like when you're talking about distributed systems, the main problem is synchronized state, right? So you might heard of different strategies like mutual exclusion, that everyone has a lock, and the resource has a lock, that you all compete for the lock, and when I have the lock, I'm allowed to write it. Over time, the more agents you have in the system, the longer it takes to get a lock, and you spend more time trying to get a lock and actually doing the job. The second quite relevant to our context strategy is optimistic concurrency, which is now, I'll get the state, I'll merge locally, and I'll push it. And if you ever use subversion, you know this is a bad idea, because you spend all the time merging conflict. So the single write principle is a way to avoid collisions, to avoid the business logic leaking, and to scale. So the idea is we're going to have one service that actually is the gatekeeper of that domain. And if you want to do anything, you go through it. You say, look, I want to update a new Doodle. I want to delete a user from the Doodle. I want to change the state of Doodle. This guy will know all the business logic. Okay, you can do this, you can't, and publish the events and publish the state. And so it's very nice to CQRS flow as well, no? Write and read, write and read. It's like a circle that you want to do. So today, that's where we are. So we have a core platform. We have a core layer in our platform. And this core layer, we have all the asynchronous, truly asynchronous service. I pictured just the single writers here because it was relevant for this talk, but we have more services here that they don't know about the world. They just know about Kafka. And then at the very edge of the platform, we have what we call the BFF, so the backend for frontend. So imagine that your application, your web application has very specific query needs. You need to join domains, you need to do some pre-processing, you need to optimize for filtering. So what you do is you create your own state, your own local state, and then you can actually serve that through the web. And in the middle, we have something we call the integration layer, which is doing what is really tricky here is this layer here is all REST. The web is REST, and you can tell me, oh, you could use sockets. Yeah, okay. So good luck changing all the apps you have now. No, you won't. And good luck hiring people that know how to handle these things here. So why don't we do this layer here what we know to do, which is RESTful, which is blocking. And this layer here is completely asynchronous, scales to whatever you want. But in the middle, we need someone to integrate this both. It's not very simple, because how do you go from a synchronous request to an asynchronous request, which doesn't exist, right? How do you integrate these two? So there are a few ways to do it. One way to do it is to use the request reply pattern, which you send which topic and which partition you want to reply. So we can just listen to requests and responses there, and then we merge, and then you can reply to the web. And another way is we thought is this is just a way to simplify things because when you look at the case again, we sat down how do we use data, and you saw that most of the cases a very simple REST endpoint here to create a user or to get something will do the job. So let's just create that, because we abstract away all the complexity of this thing here for these users here. So if you have, of these engineers, if you have a full stacker here, they don't need to know about Kafka. They don't need to talk about asynchronous. They need to know about the capitalism. They just call RESTful endpoint. That's where we are. That's where we're building a moment. So the conclusion, so what I think it's all about, was about. No. How you use your data is as important as the data itself. It doesn't matter if you have heaps of data, but if the data in a state that you can use it, as good as none. And be ready to accept some hard truth. And this is quite hard because we need to convince people they don't understand the technical details. So we need to go to the business stakeholders and go and say, look, we need this because of that. And at Doodle, we are very fortunate because our management team is really technical for the one I'm used to. So it's really easy to explain that. But if you go to someone that doesn't have a clue about this, it's quite challenging. And if you don't do that, you're going to have a hard time. And second, like, make sure you explore your tech stack strength, because sometimes you want to do something in a very cool way, because it's cool. Let's use, like sockets, let's server-side events, let's put, but no, we have like a whole environment here. Why are you going to rebuild it just because it's cool? Let's use what is in there. So that's it for me. I want to invite you. There's a link here on the top, which is on one of the new products. If you want to meet me at any time, you just follow this link and just book a meeting with me, like a coffee, a lunch, then you can do it, or you just send me an email. Okay? Thank you.